We're just doing some additional items. May ugly mug downstairs. So again, this video is covering some topics concerning it's either window light, which is a product of Sheds for Systemi. Again, my thanks to the people from Sheds for Systemi when I asked them if I could use their window light software for teaching my students. So they said yes. Mm. So again, I'm including them in the video since the content sometimes goes towards their product. Okay. The other one is the openplc.com or .org. I keep forgetting if it's org or com. Guessing it's com. No. Okay. Open PLC. Let's do a Google search. Autonomylogic.com. So that's the reason why we're not seeing it. Again, this is the other software that makes things possible for the topics that I discuss. Okay. So let's proceed. Okay. So let's type in OpenPLC editor. When launching OpenPLC, okay. So you can see it's kind of small. Okay. So let's create a new project. Again, with OpenPLC, when you create a new project, you have to go into the documents folder and you have to take care of the folder selection first. So let's call this one a new folder called Latching Inputs. So when I did a inventory of the topics listed, I actually found out that I wasn't able to discuss on the OpenPLC subsection, which is created this year, versus the uh, PLC ladder simulation logic 2 software that I used previously, the latching setup. Okay. So again, we'll have to add in our input variables. So in this case, we'll say into, okay, and we'll dictate this as a Boolean value and set state the location, which is ix0.0. Okay. And we don't assign an initial value. Well, we can assign an initial value to it, pero sometimes it creates problems if you do that. Okay. So better just leave it be. Okay. So in 3, which is pin number 3, so this is equivalent to D2 and this is equivalent to D3. Okay, to be more exact. Okay. So next we'll add in an output which is output or out 3 in this case. So my favorite is out 3 because it's D13, which is interface with a LED for Arduino Uno. Okay. So in this case, I can assign an initial value, which is 0. Okay. So it's safe to assign if it's an output. It's not that safe to assign it any initial value to it if it's an input. So this is the common policy that I use when trying to create ladder diagrams. Okay, so we begin with the left rail and we end or terminate with the right rail. So now we place in the input normal, okay, into, and our stop button, which is in 3. So yun yung category niya. And our output or out coil, which is out 3. Okay. So the problem for this one is the latching aspect. Okay. So if we run it, or if we run operations using it, this is a simulation for this one. Okay. So let's put in two, in out. Okay. So if we place in a true value here, and toggle this one, we can see the out value also becomes true. Okay. The problem is if we are working with actual objects, we typically deal with push buttons or push button switches, not really switches that are, in this case, this sort of mechanism, okay, which is the sort that we typically use for this one. Okay, so here comes now the situation. If it is a push button switch, it is a momentary close once you push it down. Once you release the switch, it goes back to an open condition. And we all know that an open condition kills the output. What if you want the input to have a value which is specifically set? Once you push the push button down and you release it, the output should still be on unless you press the start or change the false condition of in3 or the stop button in this case. Okay. So this is the conundrum that we're in. Okay. I'll show you two ways to go about this one. So this is the traditional way of going about it. Okay. We add in another input, but this time we sort of put in out as an input. Again, in standard logic, this is somewhat possible. Okay. If you look at Morris Manus' book, digital circuits, okay, book. But he calls it as a sequential type input, meaning to say you are not working with combinational circuits anymore, which is an AND in this case, because this is actually an AND situation for in one and in 3 prime is equal to out 3. Yun yung ibig sabihin yan. Okay? So what happens here is that you are reintroducing the output as a possible input. Okay? So ganyan yung nalabas with this one. So we need to connect this one into a rail. So we need to make 2 rails, one to accommodate into, the other one to accommodate out 3. And we put this one into the connection here in 3. Okay. So let's try the simulation once more. So let's press in. So this latches, true na siya. Okay. So this is already true. And this is already true. But once we have that situation there, when we change it out, it's still the same. True pa rin siya. The only time you get a change out of it if you change this one to a true condition, and you basically remove the other side. Okay. Theoretically, we can do this for a relay circuit. It's possible to do that for a relay circuit, particularly if you have multiple relay contacts. It's really possible to to do it. It's a trick that they employ for latching inputs for cheaper control circuits, particularly for some of the factories here, from which are Japanese factories here in the Philippines. Okay. I once had a student of mine, I think 13 or 15 years ago, tell me na we did the course for PLC then. And he was telling me, sir, I don't think we really need PLCs. So sabi niya, why? Because in the factory that I worked in, I forget the name of the company, they don't employ PLCs. They just employ um, relays which are programmed as PLCs. Okay, so apparently he had to relearn everything from the PLC side, but he says that PLC programming helps to envision all of those things. Okay, so this is one way to do the same action. Okay, so let's stop. Let's add in another output. Okay, this is out 2, and this is now pin number 2. Okay, so we'll remove this one, yung D4 natin. We don't need that. We can just use the same structures, except we're going to use to create a new parameter set for this one. So we'll use 2 uh, inputs in this case, and we'll use a functional block. So the functional block that we'll employ is the SR, standard, under standard block, RS to be more exact. Okay. Why RS? Because RS is a priority for the setting. Okay. So in this case, I will have in3, which is my stop button, connected to the reset line here. And I will have my start button, which is 2, connected to the section here and connected there. And I will have my out, which is again uh, out 2 in this case, so that I don't anymore have to worry about interference with out 3. Okay. And we'll add in a right power rail to terminate the connection. Okay. So this is the other way of doing it. Okay. So let's compile. Okay. So here we got an update. Out 2 came out. Okay. So if I press in to here, you can see both of them are 2. If I press in if I toggle this one, sorry, hindi pala nag-on, false na siya, you can see there's still both 2. If I turn on this one, you see that we have the value operated there. Okay. So it's kind of something that does the job, okay, so to say, okay, but you still have the decency of having an output present. Okay, so I'll pause this one for a bit. Okay, we'll pause the recording so I can launch Tinkercad. Okay, we're resuming recording now. I'm on Tinkercad. So let's proceed to get a relay. Okay. So we have a relay which is dual pole, dual throw. Okay. So we have two switches in this case. Okay. So let's get a battery or a supply. Okay. So the nice thing about this one is that it comes with a power supply to match things out. Okay. And we need to get a load. In this case, typically it's a light bulb. Okay. Now we also need a input switch. Okay. So we have push button switches here. Okay. So the push button switches will have to be interfaced towards terminal 16, which is the coil natin. Okay, so that's one. This one is the return line that goes back there. This one goes or should go towards the positive side natin. Okay. So let's decolor it towards red so that you can just see or you have the ability to see how this one actually turns up. Why am I saying that it can be implemented in an actual relay circuit too, instead of just having to deal with a specific type of scenario wherein you just use a PLC. Okay. So mamaya we'll change the color of this one to orange, orango. Okay. So this should be terminal, this one. Since we have three here, we have one, which is this, two, which is this one, three, which is the other one. Sorry, should be there. The last one. Okay. And then we have the other one, which is the third one, being reconnected towards the ground terminal that we have. Again, we recolor this one to green, okay, so that it matches the return line color. Okay. For AC kasi, the return line color is actually commonly yellow or green. In DC, we always use black. Okay. So let's start the simulation. So you see the bulb is not turned on. When I click on it, the bulb turns on. But because the momentary switch that we have here kind of gets in the way, okay, when you release it, you basically get a disconnection of the circuitry. Okay. So why? Let's go here. Because the push button is somewhat this one. Ganyan siya. Okay. So when we now go into using a relay contact as another means to latch the circuit, this is what we mean. We imply now that we can take part of the coil inputs that we have towards this interconnection that we have here. So part of the coil input will now be sequenced towards that one and sequenced towards this end. Okay. So when you originally turn it on, it's not on. When we click it on, we have power going to the coil. When we release the push button, power is still moving from this terminal into the coil to this terminal and moving towards the connection point that we have. The problem now is we need a disruptor. We need something to disrupt the flow of current. So this is where you get another switch and you basically terminate this connection towards this particular switch terminal here. Okay. Dun sa isang portion. Okay. Unfortunately, a push button will not be a very good idea for this one. Kasi This is, we have to have a normally closed push button, not a normally open one. Let's just use a slide switch for this. Okay. So traditionally, you have the common and disconnection point here. So when we look at the circuitry, you see that it's basically normally closed yung portion na yun. So hence, when we turn it on, start the simulation, we press this one, it's latched. If we click this one off, we disrupt the flow of current going into the coil, and we basically are able to terminate the connection point. Okay. So this is a latching control circuitry. And again, we commonly employ this type of connections when we are dealing with uh, non-computer controlled logic systems. Do you remember the K1 computer was actually made out of relays. So this is one of the earliest example, electromechanical computer that can add, subtract, multiply, and divide. Was made out of relays by uh, an engineer, I'm forgetting, I think Bell Labs, yata, if I'm not mistaken. So K1, let's type it in. K1 computer or Kitchen 1 computer because he built it on the uh, kitchen computer table. Electromechanical computer. So this is one of the things that you would find on the computer museum pieces. It's Z3. Yung nandito. I don't know why they're missing it. But this was one of the earliest computers that you could find that can do computations. K1 or Kitchen 1 computer. Okay. So it's using again relay logic only. Okay. So that's it. Okay. So whether you're using a relay-based system or you're using a PLC program, the general line of thinking is the same. Parehas lang sila. You're just basically employing logic operations. Okay. So that's basically how we fit everything here. That's all for this video. Thank you for watching, and hopefully you would find this useful for your unit tests. And stop recording now. Thanks for watching.